This is lecture 10, Logistic Regression. Today I discuss residual diagnostics. Residuals are the discrepancy between the data values and their predicted values from fitted model. A residual analysis detects outliers, identifies influential observations and diagnosis the appropriateness of the logistic model. An analysis of the residuals should be conducted before a regression model is used. Unfortunately, the residuals are more difficult to define in logistic regression than in regular multiple regression, because of the non-linearity of logistic model, and because more than one regression equation is used. Before discussing logistic regression, we discuss data configuration first. So, data configuration. When dealing with residuals, it is important to understand the data configuration. Often, residual formulations are presented for the case when each observation has a different combination of values of the independent variables. When some observations have identical values of explanatory variables, or when you have specified a frequency variable, these observations are combined to form a single row of data. That means, suppose we have capital I group, and this group formed using the fact that for the first group the values of explanatory variables are same, and for second group the values of explanatory variables take other unique value. Similarly for I group. Suppose I have n total number of observation, and we divide this capital N observations into I groups, where first group contains small n observation, second group contains small n2 observation, and ith group contains capital Ni observation, such that sum over small ni, I from 1 to capital I, equal to capital N. The response indicator variables denoted by small ygi for original observations, and it is replaced by two variables wgi and small ni. That means, for consider group 1, and it consists of ones and zeros. So W G, for here G is take two values, either 0 or 1. So y0i means 1, y0i means 0, response when response is 0, and y1i is 1. Now this wgi, when g takes small g takes 0, then w01 for group 1 is a number of ones, total number of ones, total number of zeros, total number of zeros W11, total number of ones, and this group size is small n1. Similarly, we define WGI Ni for other groups. So here G equal to 0, 1 and I small I is 1 to capital I. Simple residuals. Each of the capital G here I consider only two values. If it is more than two values, then you can use your small g varies from 0, 1 to capital G minus 1 if I take capital G values. So here I consider only two, I take only two values. So for each of the two logistic regression equation, that is one for one logistic regression for 0 and another logistic regression for 1, equation can be used to estimate the probabilities that the observation of independent or explanatory variables here I consider one explanatory variable to illustrate this residual. So I write variable values by xi belongs to the corresponding outcome group pi gi probability y equal to small g when we use xi value, that means the value of explanatory variable corresponding ith response. Then this is pi naught I, then this is equal to y equal to 0 given xi, and pi 1i, this is equal to xi, and pi naught I plus pi 1i equal to 1. This estimated probabilities can be compared to the actual probabilities occurring in the database by subtracting the two quantities, forming a residual YGI minus pi gi hat. I denote this by smaller gi. Where small YGI is a actual value and here we observed that there are two residuals. Why? See, YGI, it takes 1 or 0. Each response takes 1 and 0, and you estimate pi gi hat. Actually, when YGI, that means ith response is 1, then you use simply pi hat, and when your actual response is 0, then you use 1 minus pi I hat. So this is the difference between the residual for logistic regression and the residual for multiple regression. In multiple regression, the residual EI equal to yi minus yi hat. But in logistic regression, the residual Ri is yi minus pi gi, where I denote it ygi, then this should be two values depending on ygi. If yi take 1, then it is 1 minus pi I hat, and when it is take yi take 0, then it is 0 minus 1 minus pi I hat. So here the residuals are more difficult to define. So note 1, this makes residuals analysis much more difficult. Next, note 2, if the logistic model fits, if the logistic regression model fits an observation closely, all its residuals will be small. Note 3, when ygi equal to 1, then pi gi hat will be close to 1, and this is equal to 0, then pi gi hat will be close to 0. Note 4, unfortunately, the simple residuals have unequal variance, and it is equal to ni pi gi 1 minus pi gi for group I, where Ni is a number of observation with the same values of the independent variables or explanatory variables as observation I. This unequal variance makes comparisons among the simple residuals difficult. So this unequal variance makes comparison among the simple residual difficult, and alternative types of residuals are necessary. Next, Pearsonian Pearson residuals or popular alternative to simple residuals are the Pearson residuals, which are so named because they give the contribution of each observation to the Pearson chi-square goodness of fit statistic. When the values of independent variables of each observations are unequal, the formula of this residual is chi I for ith observation plus minus root over sum over g from 0 to 1 y gi minus pi gi hat whole square divided by pi gi hat I from 1 to small n, where small n is total number of observations. Negative sign is used when YGI equal to 0, positive sign is used when YGI equal to 1. You can check that. This is your homework. This is reduced to yi minus ni pi I hat simply pi I, yi minus pi I hat by pi I hat. Again, if we group whole n observation into capital I groups, then the ith residual corresponding to ith observation is equal to, this should be WGI minus N I pi GI hat whole square divided by Ni pi GI hat. So please rectify the previous homework. So if you use YGI pi GI hat whole square for ungrouped case by pi GI, then this should reduce to yi minus pi I hat by pi I minus 1 pi I hat minus 1 minus pi I hat, the previous case, and in this case it should be equal to yi minus ni pi I hat by previous case it should be yi minus pi I hat, yi minus pi I hat whole divided by pi I hat 1 minus pi I hat when you consider the ungrouped case, and for grouped case we use this residual and it is reduced to yi minus ni pi I hat by root over ni pi I hat into 1 minus pi I hat. So this is your another homework, and here plus sign used when WGI by NI is greater than pi GI, minus sign is used when WGI by NI less than pi GI. So this is your second homework. I repeat, first homework also. The first homework is when for ungrouped case you use YGI minus pi GI hat by pi GI hat. So you check, this is your first homework. So this is equal to yi minus pi I hat by pi I hat into 1 minus pi I hat root over pi I hat into 1 minus pi I hat. This is your second homework. The first homework. So next we discuss Deviance Residual. Deviance statistics D defined as minus 2 into difference between log likelihood of a residual model and saturated or it is better to write minus 2 into difference between log likelihood of your reduced model instead of residual. Sorry, it should be reduced model and saturated model, and this is equal to minus 2 into small l stands for log likelihood and this is for reduced model minus small l is for saturated model, log likelihood for saturated model, and this is simply equal to minus 2 into I from 1 to small n g from 0 to 1 log pi gi hat. Sorry, here it is. YGI. So this is equal to YGI into log pi gi hat. check. So the deviance residual are the square roots of the combination of each observation of the overall deviance. Thus, the formula for deviance residual is equal to, I denote this by di dash, this is equal to plus minus root over 2 into g from 0 to 1 ygi log 1 by pi hat gi, and when ygi equal to 0, then di dash takes negative sign, and when ygi equal to 1, then di dash take positive sign. And similarly for group theta, for group case, the residual deviance I denote it dj or di for ith observation, di dash for ith observation, dash because of when you use group structure, and for ungrouped I denote, for group structure I simply denote di, and when for ungrouped structure then I use di dash. So di equal to plus minus root over 2 into sum over g from 0 to 1 wgi log wgi by ni pi gi hat, and wgi by ni greater than pi gi hat, then di take plus sign, and wgi by ni less than pi gi hat, then di takes minus sign. Check that sum over di square is nothing but a deviance statistics. We will continue our discussion on logistic regression. Please stay with us. Thank you.